and welcome to kind of a bonus discussion. And I thought I would go through and try to give transfer learning a bit of treatment. So this isn't really something that's explicitly covered in the course, but probably should be. It's really pretty relevant when we start talking about big data and also dealing with deep learning models. And the part of it that's really compelling is it allows you to kind of like learn from one thing and use it somewhere else, right? So fair question on any topic is, well, what is it? So as I just said, the idea, whenever we're doing traditional machine learning, we basically have some data, we train a model, and we use that model. And they're pretty much kind of independent of each other to a large extent. Whenever we do transfer learning, the idea is that you train for one situation and then potentially use it in a different way, so in a different domain. And it's one of the powerful things about deep neural networks is that you can do that you can take the concepts that were learned in one space and apply them elsewhere. That's kind of like what we do as people. If you think about it, we oftentimes learn by associating something to something else that we already know. So if you're learning how to drive a tractor or a lawnmower, and you already know how to drive a car, you're using a lot of those same skills, even though it is something that's a bit different and potentially some very other kind of behaviors going on. Especially when you talk about something like a zero-turn mower, where you're using levers to go control which way the wheels turn on each side. Still the concepts are very similar, and we do that inherently ourselves. We also kind of can apply the skills that we learn in one sort of domain to another. For example, if you're learning to write programs, each time you learn a new programming language, it's not necessarily starting from scratch, right? You start from a set of constructs and a set of things that how do I do this in this language? And so that is an important concept. The hands-on transfer learning out of O'Reilly is a good resource. That's where a lot of this material that I'll cover today came from. So it's definitely worth a quick look, although it doesn't really get into transfer learning until probably about chapter 6 or so. The first 5 are kind of a generic deep learning sort of thing. So why do we do transfer learning? There's lots of different reasons. The end result, though, is that it results in better models. It also gets you there quicker. You start off by initially doing much better, right? Because you're leveraging that knowledge that you have from some other domain within your new domain, and so you're going to just inherently, because you're dealing with a pre-trained model, out of the box be doing better than you would have otherwise. And so that it also, as it is training, increases quicker. So the angle of the line is steeper, and we'll talk about that in a moment with a visualization. And then at the end of it all, your overall results are better, right? So you do better to start, you do better as you're moving along, and then at the end, what you get is better than what you had when you started. And this is kind of an interesting concept, because it's applicable in situations like maybe you've got a model that knows how to do some sort of text processing using natural language processing on a document. An example of transfer learning is to do it on a different language. So to switch from English to Spanish and process a Spanish document using most of your model. And you basically kind of change pieces of it. So like the end layer might be different, or you might do some additional tuning along the way. But you start with something that is pretty well done anyway. So to restate what I just said, why do we do this stuff? You start off higher than you would with just a random model. Because whenever you're doing this, its weights are already in a pretty good shape. And so you start better. You also learn quicker, so it takes less epochs to reach the level of accuracy that you're interested in and to flatten out. And when it does flatten out, it's going to be at a higher level. So if you train two models, one of them with transfer learning and one of them without it, you're going to see the one with the transfer learning is going to do better to start, get better faster, and be better at the end of the experience, most likely. These are generalizations. There's always exceptions to everything. But this is part of the reason why we do that. So what is it really, right? So a fair question. I've done some hand waving and some talking. So to do that, we have to kind of dig into some terminology. And so when we talk about transfer learning, there's different types of transfer learning that one might do. So one is around the concept of the feature space in which you're working. And so that's basically saying that there are differences between a source and a target. So you trained it on the source, you're going to use it in the target. And those features are different. The example of the document classification, maybe you're wanting to determine if an email is spam or not. So you might do that in English, and then maybe you want to do it in a different language. So maybe in French, as an example. You also have this the idea of domain adaptation, which is where your marginal probabilities are different between the source and the target. You've also got this concept of label space, and that's where you're labeling things in a different way. So there's kind of a bit, obviously they're different, but that's kind of part of this concept is of you're potentially applying some sort of additional labels. And then there's also this concept of conditional probabilities that may be different. So the basic idea is that your differences in the different domains of conditional probabilities may likely be different as well. So whenever you're deciding if you want to do transfer learning or not, there's some important questions you kind of ask yourself along the way. One of those is things like, well, what are you trying to transfer? What is it that you're trying to transfer? When are you doing that transfer? Is it kind of intuitively going to make some sense or not? And sometimes it could make it worse. That's that concept of negative transfer, where you would be better off just doing a random, starting at a random point with your model and start training. And then there's the question of how you're going to transfer. So you know what and you know when you're going to do it. So then the question becomes of how do you actually go about doing that transfer? And that's going to be most likely related to changing the architecture, at least on probably on the end of your neural network, right? So you're going to potentially change that output layer, and maybe one back even, and you might even do a certain amount of adjustment back further. So when we dig into the various kinds of transfer learning, this is from the article at the bottom of the screen. It's a pretty good article, but it's coming up with essentially kind of an ontology of how do you think about this stuff. So how is it organized under this broad umbrella of transfer learning? And you have the concept of a labeled target domain, a labeled source domain, or unlabeled source and target. And in that world, you're over there in unsupervised transfer learning. Most of the stuff that we deal with here is going to be related to the inductive transfer learning. So you're basically, the source and target are trained simultaneously, and it's essentially multitask learning when you do that, or it's self-taught learning where you have basically an unlabeled source domain. The transductive transfer learning is whenever you do have labeled source, but only for or do have a labeled source domain set of data, but not necessarily the target. And then you may be doing it as a single task that are disparate, or they may be combined together, and that's where you're dealing with things like covariance shift versus domain adaptation. So there are relationships between these types of things. Whenever we're talking about traditional machine learning, the source and target domains and the source and target tasks of what it is you're trying to accomplish are going to be the same, because it's traditional. That's kind of how we do it. When you're dealing with transfer, there's these different types of the inductive, the unsupervised, and the transductive transfer, just as we talked about on this previous slide. And so whenever you're doing it in an inductive transfer, the source and target domains potentially are the same, but the task is going to be different, but they have something to do with each other. Unsupervised transfer learning, both the domains and the tasks are different, but they do have something to do with each other in some fashion. They're related somehow. For example, you're probably not going to do take a neural or a natural language processing model and try to use it to do image classification. Probably not going to go real well, right? So they kind of, but you might do something where you're doing object detection and you modify that to do classification of objects inside of images. So there's things where they have something to do with each other. The last kind of combination is the transductive transfer learning, where your source and target domains are different, but you're trying to do basically the similar sort of task. So we do have also this concept of an instance transfer. That's where you're reusing knowledge from the source domain to the target task, and it's what it's kind of intended to do. Most of the time you can't reuse the source domain data directly, so you're not going to necessarily be augmenting your training data set with some other data set and think it's going to work out. So rather, instead of that, you're reusing essentially the result of the training on that data, and then you take your own data to improve the results. So when we talk about deep learning and doing transfer learning, it is typically doing the inductive learning, as I mentioned. And basically what it means is you're kind of restricting to some extent the hypotheses that it's testing based upon you've already removed a lot of possible hypotheses. So you do have this concept of, to make this all kind of work, you have an inductive bias. That's a set of assumptions that have something to do with a model that have been basically figured out through the training process. That inductive bias is how the whole generalization works. That's where a model sees something it's never seen before and does a reasonably good job. Models are considered to be good whenever they handle data that it's never seen before in a reasonably way. Maybe it's not perfect, but it's not horrible. And that's basically how we're doing this inductive transfer, is we're taking advantage of that bias and kind of the generalization, and you're taking that generalization kind of a step further. So you're kind of fundamentally changing the structure of the outputs typically, and we can go into that here. So the diagram's kind of upside down from how I normally think. Input data is at the bottom and output at the top, and basically what you're doing here is getting rid of kind of that last softmax function and instead using something like a classifier on it. So you're using pretty much everything up until that point except for kind of that next to the last one, and maybe even probably the last one as well. So the real benefit of this stuff is that you can use pre-trained models rather than having to do a whole bunch of training yourself, right? So that's where it's such a cool thing that Berkeley has what they call a model zoo. And the idea being it's a collection of various pre-trained models. Also, you'll notice a lot of the deep learning frameworks have the ability to essentially create something from an instance of a pre-trained model. So I've been working on that transfer learning with the cats and dogs, or the dog breed classification, and it's been giving me grief. So let's go ahead and get over into a terminal. And basically I'm finishing up installing Pillow because I was trying to get something to work earlier. And I'll go open up Jupyter Notebook. If I can spell it right. and it should pop. And navigate to the folder. And it is in this hands-on transfer learning, and chapter 6 is where they start going through it, and even if I can't get it to run, I can still talk through it. So this is based off of Inception v3, which is came about through some work Google did quite a while back, and so obviously it's the third version of the model, which is based on ImageNet, and it's essentially a pre-trained model is the takeaway. So when we go through here, I'll see if this will work. We do our typical sort of includes. We pull in NumPy pandas, a random number out of NumPy. Then we do some setting the max column width so that things won't truncate or whatever. Pull in sklearn for the model selection, primarily so that we can get a train test split, so we can split our stuff. And then the pull in all of the Keras stuff, all of which is now underneath of the TensorFlow namespace. The book's not that old, but it doesn't catch that that stuff moved. One of the interesting things I learned along the way is how to pull in data from Kaggle. This uses the data set up on Kaggle, and this may be old news to you, but there is this API, so you can basically go and install the API, and what it does is then lets you be able at a command prompt to issue a command that you get from inside of here. So this Kaggle competitions download -c and then dog breed identification, once you've got it configured correctly, and you have to put a JSON file in a certain location with your essentially your token, which you get from up here. So in your account, you request an API, generate a new token, and it'll give you a file that you place that kaggle.json in a certain location, and then you can use after you've installed the command prompt version of it, you can actually download the data from there directly without having to go through a lot of other stuff. So once you've done all that, because the authors can't really distribute that, had to make a couple minor changes to the code, but the train folder and the test folder and then this labels.csv are all in that same folder. So if we drag this over, and you can see this is the file I downloaded. I probably should delete that because it is really pretty big, but one of the things that came out of that was this labels.csv. Go ahead and open that up, and it's basically where they're labeling the data set based upon simply the ID of the image and the breed that they belong to. So if we go into like test, you can see there's that same sort of, looks like a GUID minus the dashes, and so that you can then see the various breeds. So that's what it's going to be training on. Or transferring on. So then we basically can go ahead, and it says that there's 120 breeds, looks like. And then you have to go through and do some pre-processing of basically kind of setting up your data so that it can be encoded correctly. And then where it's been dying on me, I think is somewhere through here, where basically we're trying to do this is basically reading the folder, the file system into memory, and it takes quite a while, and it's kind of unnecessarily long, because this machine has a solid state drive, right? So see if that's where it's at yet, or if it's doing something else. Maybe it's not there yet. But yeah, we're running this cell right now. It takes several minutes. I'm not going to sit here and wait for it. So moving on through, we then go through and we split it 70-30, and with a repeatable random state so that we can see what's going on. And then basically, looks like we're splitting it again there. Oh, that's for the validation set. So creating a test train, and then they're also taking, it looks like pulling off a certain amount of it for validation. And then we can go through and basically it's doing some data augmentation where you're basically kind of adjusting some of the samples and so on. And it's actually making some variations of different samples, right? So this is where you're doing that kind of doing some manipulation to the image to essentially, it's not quite fabricating data, but it's augmenting the data by doing a certain amount of creation of it, if you will. And so it goes through and is doing that so that there's a representative number for each one of the breeds. And then we go through and basically set up our classifier, and they starts off by loading Inception v3 using the ImageNet images or weights without its top classification layer, so it's missing the very last layer, and then we add some additional layers on top of that, right? So this is a pretty good exercise that you may want to go through if you have the time. And so one of the things I wanted to do while I have time, before I don't want to drain all of that, I'm gonna go ahead and interrupt this so I can show you something that's pretty cool. And I ran across this today on a different sort of tangent. And you may be familiar with it. I was not. And it's cool enough that it's worth talking about. And again, I'm not, I saw it today. So not a master of it, but it is pretty cool. So it's called Bambu Lib. Maybe you've seen it, maybe you haven't. So what it is a kind of graphical way, or an interactive way of interacting with your pandas. And you don't necessarily have to do a lot of things to get it up and running. So the way it works, why is it? Okay. That's interesting because I had this working earlier. Yeah. Huh. Well, maybe I was in a different environment and didn't realize it. So maybe it's just in my base. But what it is a library that essentially allows you to interactively manipulate pandas data frames. And to the point, it writes your code pretty much of most of the common sort of functionalities. It's kind of in that augmentation sort of thing, not so much machine learning or something to generate code based upon some requirement, but rather as an aid to help people get up and running quickly without having to write a bunch of code by hand. So it obviously relies on Matplotlib and actually can do things like help you create visualizations using Matplotlib. And the cool part of it is that you get the code, right? So it actually writes the Python that you need to do it. Let's see if that's all it needed or if it needs something else. I'm gonna, well, I guess I started down this path, so we'll fix it. So it needs SciPy for whatever reason, for some of its scientific processing. I'm wondering, I must have been running in my base environment, not there. So to get started with it, while it's doing that, you can come in and basically say get started for free. And then there's a community edition, and you click on it to go get started. It makes it pretty easy to do. You say you want to install it on your computer, or you can also use it in Binder. Binder's kind of cool. Although that's probably a premium sort of thing. So if you click on how to install it, it takes you to a nice little page, and they even give you a nice little script to basically do it for you. And I swore I did that. But at this point it's going through and downloading SciPy, and it should have taken care of it by when you install something. Generally you get your dependencies as well. So once you get it installed, whenever you render a pandas data frame, so if you just say df and hit enter after you've constructed a data frame, it pops up with a little button on there to do some stuff. And so once you've done that, you can actually start using it. So you can we can use our good friend Titanic to do some data exploration and so on. And it should be in about 40 minutes or so, 40 seconds or so. So the idea here, though, is that you can then quite quickly get it up and running. The reason I ran across this was I was talking with some people from Databricks today about the desire to basically have a simple way of producing a rule-based approach. This is not exactly what this is, but they mentioned that Databricks had just recently purchased this 808 labs, so 8080 labs, so to do tighter integration with that offering. So it does make sense, and it is a very cool way to get up and running quickly, right? So oftentimes we forget a certain syntax because we don't do it often enough, and so it helps you by kind of guiding you through the process, and being able to actually interact with it. All right. Let's see what else it's going to complain about. Let's just try this. Let's see if this is where I put it. Yeah, here we go. Much better. So let's go ahead and delete that so I don't accidentally run it. So what I did here, this is code that they pretty much provided. Bamboo Lab has the ability to just pull in the Titanic data set from itself, so it installs it for you. And so whenever you do this, the only thing that's kind of new is you get this little show Bamboo UI, right? And what that does is pop open this idea, or this interface. And so then you can start things like maybe I want to filter rows, and I want to select certain rows based upon, say, age, and I want it to be greater than 17, and I want it to be less than 50. And whenever I do that, see what it just did up here? It actually wrote our code and re-evaluated it again as another data frame. And so if we want to, we can do this sort of thing and basically switch it down here and run it down here instead, so that you're then getting, this is the original version, this is the data frame that was created as we made changes to it, and you can also change that. It does some neat stuff here too as well, such as lets you do some exploration of the data. So you can come in and take a look at the data with Glimpse and basically see that there's 177 ages are missing, so 19.9% of the data is missing, and 77% of cabin is missing. So that's a significant thing. You can also take a look here and see what is a good predictor. Taking a quick look at it, and you can see, especially if we want to do survived, that's the one we really care about. We don't want to see everything combined together. Let's see. I think it is all columns and survived. And you can see survived, sex is pretty important, as is the ticket and the fare. So interesting sort of stuff. And you can see a correlation matrix between survived and class and fare, and usually gender matters on that as well. But some pretty cool stuff to just do some data exploration. Excuse me. You can also create plots off of this. So you can do a histogram on the x-axis. Maybe we want age. And then you can also say I want the color by sex. So you can see the various things. And you can actually, if you're so inclined, take a look at the code, right? And potentially copy it if you want to hang on to that for something else. So not that it's a end all to be all, but still kind of very cool, right? And more importantly, how often do we come through and say, okay, I've got a data frame, I want to do something interesting here, like I want to do a group by age and I want to calculate the mean and count and min and max of all columns, and I'm going to make a new table and I'm going to call that df2. And if you don't include a string column, it'll actually do it correctly. Probably that. So anyway, like I said, just started playing with this, so maybe I'm going a little too. Oh, that's why. It's because I'm doing all columns. Mean, max, median of. Let's do sex, but then we want to group it by survived. And again, I must still be maybe it doesn't like the so it's something is definitely. Yeah. Anyway, so you get the basic idea is that if you know the tool, There we go. So once you can figure out the tool, then it can start doing things to make your life easy or easier. So may or may not be worth the time to figure out, but it is kind of cool, right? And especially when you start dealing with some of the data exploration tools and so on. And doing fun stuff like this that we don't particularly necessarily want to do ourselves to clean up and deal with the aggregates and all that good stuff that we sometimes have to do. So with that, I'll go ahead and wrap this up. Sorry to hear about your computer dying. Fortunately, though, you have your stuff backed up on the cloud. So if you need any assistance with anything, let me know. Stay safe, and we'll talk again on Monday. So I guess since we won't speak before then, have a good weekend. If you have any questions, do let me know. Be glad to help.